this was our actually the recursive code that we coded in the previous lecture on the Leet code. If you see like whatever the raw, right, this function is given, we are taking like we are passing this number, right, num array to the length minus 1 because this is the last index. What this function is actually doing is the base condition, whatever we have discussed. If n is less than 0, we are returning n. And again the same thing that we have discussed, right, the max of if you included the current number, then the adjacent to adjacent. If you not included the current number, then your adjacent, whatever is the max in that, you will return it. Now what is the problem into this approach? Again, you will see the overlap problem. Like I can explain you with one of the example. So suppose 1 2 3 1, this is given to you, right? This is the number. Now what you will do, you will pass this to this, right? So you have f of 1 2 3 1. What it will do, the first condition is not satisfying, so it will actually open two cases. If you are included, like you are standing on here, right, you are standing on the last position, your I equals to length 3 0 1 2 3. So what it will do, it will do the numbers, it will open this recursive relation, that is -2, like I -2. So till actually 1 0 1, 3 minus 2 is 1. So it will have function of 1 comma 2, because now you have only two choices left. If you included 1 plus num of 1, means plus num of 1 is number of I, that is 1. So either you can take 1, right? If you taken 1, then you can't take 3, so you will have 1 or 2, function of 1 or 2. If you're not taken 1, then you have function of 1 2 3, the remaining, right? So whatever is the max in this 2, that will be the answer of this, right? Similarly for f of 1 or 2, you have two choices to solve f of 1 or 2, right? You can either go to so here your I is 1 and 2, 0 1 1, right? So you have I minus 2, 1 minus 2 is f of minus 1, I mean -1, that will be the whatever is there. Array is not given, so actually it is the -1. And if you have chosen this, then you have 2 here. So this is actually the base condition here. This is the leaf node, right? And if you haven't included let's suppose 2, then you have only this, that is f of I minus 1, that is f of 0. Okay. So these are the two conditions. Either you can choose f of -1 and 2, or you can choose f of 0. To solve this, again you will have two conditions. If you included 3, then you have the remaining, you 2 can't you choose, so you have f of 1, right? If you have not included 3, then you have f of 1 comma 2. These are again the two conditions. Both max here, max here. So if to solve this, f of -1 actually it fall in the base condition. It's less than 0, so it will return 0. So this will return 0. This will return 2. 2 plus 0, that is 2. It will return 2. F of 0. F of 0 is actually this one, array of 0. Because you have not included 2, so you can include 1. So here it will be 1. Max of 1 comma 2. Max of 1 comma 2 is actually 1, right? So here whatever the max, 2 and 1. 2 and 1, what is the max in 2 and 1? That is 2. So 1 plus 2, this function will return 3. Now to solve this, you have f of 1 here, right? If you included 3, if you actually included 3 here, then you have just two choices, like from 1 and 2. So you just have one choices, like f of 1, that is the 0th index, so it will return 1. 3 plus 1, that is 4. So here it will return 4. And here f of 2, if you again open f of 1 comma 2, right, it will have, if you included 2, then you have 2 plus f of minus 1. If you're not included 2, then you just have f of 0, that is 1. So it will return 1, it will return 2, it will return 2, it will return 1. This function, max of this is 2, right? This will return 2. Max of 4 and 2 is 4. Now max of 3 and 4 is 4. So the answer is 4. But what's the problem here? Like, these are the recursive node, these are the leaf nodes. We know these are the leaf nodes, but these are the this is the overlapping problem. If you see that f of 1 comma 2 we have already calculated here, and f of 1 comma 2 we are again calculating. So again same problem, where whatever I explained, this is like overlapping problem in a recurrence relation. To avoid the overlapping problem, what we'll do, we'll include the memorization into this code. Right now it's not memorized, so this is actually, we include the memorization into this code, and this will actually work fine. How to include memorization? It's very much easy task. What you will do here, you will just create an array. In this code only I'm explaining. So what I will do, I will just create a memory array, something called a memor or anything. Then we'll initialize this, right? We'll initialize this here. So what we'll do, like memo equals to new array, new int, whatever is the length, right? Number of nums dot length minus 1. This is the initialization. And because like 0 is important, right? So we'll fill this array. You will just fill this array dot fill. There is a function called fill. You will fill this memo with minus 1. So once you fill this minus 1, all the elements of array will be filled with the minus 1, right? So we included the memory here in this array. Now into this, like if you have less than 0, you will return 0, that is fine. But here what you'll do, before checking this, before actually calling the recursive function, here you will add one line. One line is like, if your memory, if that element is available in memory, if memo of I greater than equals to 0, means we have replaced this memory with minus 1. Previously it was minus 1. Now we have put it something, either 0 or some value, means this particular thing we have already calculated, right? So whenever you come here second time, you will have already this entry into the array. So if it is there, you will just return it directly without calculating. You will return memo of I. So that's how we saved this call, by returning into the memory. Here you will add one line, and here what you'll do, like if you are calculating this, then you will need to put into the array, right? So here what you will do, once you have the result, you will put this into the result, whatever the result you have calculated, right? So just to include the memorization here 2-step and 2-step here. This will call me as the dynamic programming, top-down approach. So what I'll do in the next lecture, I will code this into the GitHub, into the Leet code. So this one. Yeah, thanks.